So we're continuing 3.4. Just a few examples I want to go over with you because they are very important. If you're given an equation and you're asked to graph, right, this is what you want to do. You want to take a look at some key information, some key characteristics from each equation. So the degree is something you're going to need to note. The y-intercept, okay, what is the y-intercept? Is there a constant in there? And if you're just given factored form, how do you determine that constant? We'll talk about that. The zeros, obviously, from the factors, and the multiplicity for each zero. If you put those together, you're going to have a pretty good sketch of the graph. Okay, so these are the four things we're going to take careful note of. Now, in example A here, you are given y equals x minus 1 times x plus 2 times x plus 3. The degree, all right, gone over this before, but this is what you do. You take a look at the variable term in each factor. If there is a multiplicity, then you have to take that into account. But here, basically, you multiply these terms together, and that's going to give you x, what? Cubed, x cubed. So for this one, the degree is 3. All right, that's very important to know. Degree 3. What about the y-intercept? How do you find out what the constant would be? Who remembers? Sorry? It has something to do with the constants in each. Yes, you multiply them. Okay? And so negative 1 times 2 times 3 is negative 6, right? Negative 6. Degree 3, y-intercept negative 6. You good with that? All right, the zeros obviously are at positive 1, and you can go ahead and draw those on a graph. And at negative 2, remember we're always changing the signs, and at negative 3, okay? Those are the zeros, because each factor, if you set them equal to 0 and solve, that's what you get for x. All right, so that's good, we got those. And the multiplicities, okay, so they're 1 on each of these factors for a. So, this is what you do. Now, someone asked me about sign analysis, okay? Sign analysis is fine. We don't have to do sign analysis for this. The reason why is because the degree is 3, and the other thing maybe you should actually pay attention to is the leading coefficient as well. So what's the leading coefficient? Well, that is the number 1, right? It's a positive 1. So if you have all this information, you know that a degree 3 positive leading coefficient, it's going to start somewhere down here in quadrant 3. And it's going to end somewhere up here in quadrant 1. So that's the first step to graphing this. You just need to know the end behavior, right? Because this is the end behavior right here. That's what that tells you. Y-intercept of negative 6. Okay, so negative 6, you can put that on your graph. So we have 1, 2, 3, 4 points. We've got the zeros down there. Multiplicities are each 1, so there's just a simple cross at each intercept. So now you have enough to complete your sketch. So we know it starts down here, and it comes and it crosses this intercept, right? Just a simple cross. Now it has to cross at this intercept too, so we don't know how high it goes, but you know that it bends back down and goes through negative 2. See that? Now how far does it go down here? Well, we know it goes down to at least negative 6 here. You don't know exactly where this point is. You don't know exactly where the minimum is, but if as long as it passes through the points that you're drawing, that's great. So then it comes back up, and it's a simple cross up here as well. So there you go. That is good enough for your, whoops, I didn't do that. That's good enough for your sketch, right there. Now obviously you're going to try and make the curve smooth as possible, but that's your sketch. Yes, question? No, the question is, can you start from the top here? No, you can't start from the top and do this. Okay? No, not always start from the bottom. No. Okay, let me go back to this right here. Okay, the very first thing that we did here, the degree, you know that because it's degree 3, that it has to straddle the x-axis, right? The end behavior. Now, does it start down here and end up here? Or does it start up here like you're suggesting and end down here? The reason that how you know that is because of the leading coefficient. if this leading coefficient, that is the number that you get when you get your first term there, when you multiply all those, that's 1x cubed. See that? This is the leading coefficient. It's positive. So that means that it starts in 3 and ends in 1. Okay? So that's how you know. Starts down here, it ends up here. Right? Now, if we were doing sign analysis, which some of you may remember, some of you may not, we'll go over it in another lesson. But if you do sign analysis, then yes, you would know that leading up to -3, that the function would be negative, so you know it has to start down there. But you don't need sign analysis for this. Okay? Good question. Any other questions? Yeah? No, the multiplicity, okay, so the reason why I didn't write anything for multiplicity here is because we have to examine the multiplicity for each factor. Okay, so the multiplicity is 1 for this 0. It's 1 also for this 0 of -2, and it's 1 also for this 0 of -3. So the multiplicity is not just, there's not just one answer for the whole function. It's per 0 or per intercept. Okay, so you have to check the multiplicity per intercept. Let's do the second question here, okay? So we get some more practice. Second question. I'll erase all this stuff here. Except I should leave that leading coefficient on there. Let me put leading coefficient up here. Leading coefficient. Okay. All right, so, and I'll erase the graph too. We'll do it on the same grid. All right. So for this next one, for B here now, okay, the leading coefficient and the degree, we're going to be able to find those at the same time. But this one's a bit trickier. We have a -1 here. So we have to take a -1, and we have to multiply that by x cubed. You see, you take into account the multiplicities, or the degree on each factor, times x. So that's how we get the leading coefficient, which will tell us also the degree. So what is this? -x to the power of 4. You add exponents to similar, like bases, right? Okay? So the leading coefficient is negative. That's all we need to know. The degree is 4. Okay? Everyone good with that? What is the y-intercept? Well, what would the constant be? Well, it's going to be negative, because that's just a number, that's a constant, no variable there. Negative times 2 cubed times -4. Negative times +8 times -4. So what's that going to be? +32. We're going to have trouble on this graph doing that, aren't we? Unless we go like this, 6, 12, 18, 24. Okay, let's do that instead. Has everyone got that in y-intercept? This is important to be able to get this from the factors. You know, you've got to be able to do that. And instead of multiplying it all out, expanding it all, and getting a polynomial, you can do it from the factors. So that's the main thing I wanted to show you here. Right. And then finally, the zeros are going to be, now does this represent a 0, this negative? Does that represent a 0? No, it doesn't, because there's no, what? There's no x, yeah, there's no variable. Very good. It's just a constant, so that's not a 0. We have one at -2, right here. We have one at +4, right here. Okay? And we have an intercept at 32, right there. And the multiplicities, okay, so at this one, what's the multiplicity? It is 3. So that's going to be tangent to and crosses, right? Now, where does this graph start? Does it start down here, or does it start up here? All right, it's a degree of 4, and it's a negative coefficient. So if you think about a negative x to the 4th graph, or negative x squared, that's a parabola that opens downward, right? So x to the 4th is going to be something like this. That's going to open downward as well. It's going to be a very similar shape. Okay, am I going too fast or not? Because you guys have been through this already once, right? Sort of a review. So you're going to start from down here somewhere, and are you going to end where? Up here or down here? Yeah, down. Good. So you're going to end down here somewhere. Okay. So this all should make a little bit of sense here. We're going to come up through this intercept here. All right. So now I'm going to just erase this here so I can make this a bit better drawing. So it's going to be like this. I'm going to come up. Now what's happening at this intercept? It is, ooh, that's the tangent to and crosses, right? So I can't just do this. I can't just do that. I have to make it a little bit more obvious what I'm doing. All right. So what I'm going to do is I am going to move that arrow back over to where it was. And I'm going to come up and I'm going to try and draw a tangent to and cross. See how that's a little bit more obvious? Okay? Make sense? You all with me? Now, where do I know I have to go up through this intercept. Now, what you don't know is if this is the maximum point here, and it comes back down. You don't know if this goes up and there's a maximum point over here somewhere. The other thing you don't know is if it actually has a maximum point on this side, and then this is coming back down. You don't know all that. So guess what? That's where calculus comes in. Remember I told you this is all leading up to calculus? This is the foundational stuff. But all this stuff in the middle, like, I don't know what happens here. We don't really know what goes on here, right? That is calculus. So we're going to examine that when we study calculus, okay? For now, all I'm looking for is the behavior at the zeros, that you connect all these points, and over here at 4, that's a multiplicity of 1. So that's a simple cross. It should look something like that. Okay? All right, so yeah, again, you don't need to know where the maximum value is at this point. You just need to have a rough sketch that looks like that. Okay, now I won't go through C here because I want to just make this video just brief, okay? This little lesson brief. But what you would do is you would factor this, right? You have to factor it. Before you factor it, though, you could glean a lot of information. So, for example, we have a negative coefficient for C. We have a cubic function. Hey, degree 3, right on. Whoa. Y-intercept, -4. Bada bing, bada boom. It's all right there. Now, zeros, you're going to want to factor, right? So now you factor, then you can see your zeros, and you can see the multiplicities on each. And let me see, I did this before, so the factor would actually look like -2 times x minus 1 times x plus 2. And there's another x minus 1, so that's squared. All right? So if you guys are doing this, this is something you should have come up with, I guess. And the zeros are here at +1 and -2. And at +1, we have a second degree 2, a multiplicity of 2. So let's just do this real quick. Degree 3, negative. So we're going to start here. We're going to end down here somewhere. It's going to be at +1 is going to be right here, and at -2. Okay? So this is at -2, it's a simple cross. Like that. -4 is our intercept. So you got to come down to that, at least that -4. Now here's where it gets tricky, right? The 2. That's the tangent to, but does not cross. So it comes all the way up to here. Tangent to, but does not cross. Now you're going to want to be careful on your test not to double back like I just did there. So you want to be very, very careful to come through there and make it a nice, I can't do it on the tablet very well, but you get what I'm saying. Let me just back up there. So let's say this. Okay. See that? And then ends down here. So something like that, that's as accurate a sketch for this as I need. And you can double check all that too. Questions about this? All right. Let's move to our next example here. Bottom of the page. Okay. Number 9A. This is going to be part of your assignment, number 9. So you want to do this with me here. It says, without using technology, sketch the graph of each function, label all intercepts. So what we need to do, it's very similar to the last question we just did, except you're going to have to fully factor and then, find out all that you can find out. So my suggestion here for this one would be this. Notice that you have an x term. Like all of these are x terms, so you have an x in every single term. So what you should do is take out an x first. Okay? Factor that. And then you have x cubed minus 4x squared plus x plus 6. Okay? Then you can start your factor. Now, is it okay to look at this and say, hey, there's my constant, so my y-intercept is 6? Is that right? No, it's not. You have to look at the original equation. The original equation has 0 for a constant. So we're expecting a y-intercept of 0 here, okay, not 6. All right? Now from here on in, then you would test your factors and you would fully factor. So what are some of the factors that we're going to test? X what? X plus 1, x minus 1, x plus 2, x minus 2, x plus 3, x minus 3, x plus 6, x minus 6. They have to be factors of 6, those a values, right? All right. So I'll save you a little bit of time. It looks like x equals 1 here would give us a value of 0. We plugged x equals negative 1 into here, right? That's negative 1. That's going to be minus 4. That's going to be minus another 1. So that's negative 6 plus 6, right? So as we completely factor this, it's going to be x. We are going to have an x plus 1 as a factor at least. And then when we divide all that, you're going to get the rest of your factors. All right, so this should be the factored form here. Okay, that should be factored form. And I did your metal synthetic division off to the side here, and that's where I got this one from. And I just factored this by sight, right? Just to try and know what you've been doing for years. So here are your factors. Now this represents zeros of x equals 0, x equals negative 1, x equals positive 2 for this one, and x equals positive 3 for this one here. Okay. So this is also 0 is also our intercept. Okay, that we saw that here, and we see that from one of the factors too. So if you missed it up here, you'll be able to see it here once you get it all factored. Okay, what's the leading coefficient? Well, it's positive 1. It's a degree 4, right? So we're going to be coming from down here and ending down here as well, right? Or actually, sorry, from up top. So from let me do it here. So from up there and ending up there. So what are the multiplicities? They are all 1. So this represents a simple cross, a simple cross, a simple cross, and a simple cross. And that would be enough to show me that you understand everything you're supposed to understand here for this question. Yep. This one? That's 0. All right, so the last one I want to do with you here is question number 14 in your assignment, 3.4. And it looks like this. It says, determine now the equation with the least degree. Okay, so there's going to be, obviously, there's going to be lots of different options for equations, but we're going to do one sample equation, kind of the base equation, that satisfies all of these things. Now we're doing this in reverse order now, sort of thing. And then we'll sketch. So for 14a, it says let's come up with an equation that is a cubic function. So that is degree what? 3. Now the zeros, they're going to tell us about the zeros. There's a 0 at negative 3, so that's x equals negative 3. So what is that going to show up as a factor? That's going to look like x plus 3. Yes. Multiplicity of 2. What does that mean for our equation? That there's 2 of these, or this is squared. Right? So we're just kind of building the equation given this information. All right, there's also a 0 at positive 2, so that's going to translate into x minus 2, okay, and a y-intercept of negative 18. Okay, negative 18. So what we have to kind of do here is we kind of have to think about this. You do not just do this. That's what, you can't just do that. Because remember how we find our intercepts is we multiply the basically the constants from these. So if it says that y-intercept is negative 18, what we have to allow for is that there might be another constant in front that we are not aware of. And that's how we're going to find out. Okay. So what is 3 squared? 9 times negative 2 is negative 18. So guess what? We don't need a coefficient here other than just 1. So our base equation then, because everything lines up with just this right here. And that is our answer for A. All right, another example here, B. Let's do B. A quintic function, so that's degree 5. Okay, that's what we're looking for. So let's do y equals, now the zeros are negative 1, so that's x plus 1 with a multiplicity of 3. 0 of 2, which turns out to be a factor of x minus 2, with a multiplicity of 2. And the y-intercept has to be positive 4, so that's how we're going to know if we need to have another number here. Okay, so let's find out about this y-intercept then. 1 cubed is 1. Negative 2 squared is positive 4, so guess what? We don't need anything here. That means that this is our final answer. Okay, so finally, this is the last example I'm going to do, but C is one where we do have to consider a coefficient in front. So quartic function, what's that going to be? Degree what? That's degree 4, very good. It has a negative leading coefficient. Oh, okay. What you could do is you could now go ahead and put a negative sign in front of the factors that are going to follow. That's probably a good way to do it, okay? Instead of going, oh, what, do I have a negative x in here, or how many negative x's? I would just say, you know what, just put that negative in front. That'll work fine. And it has zeros of negative 2, multiplicity 2, so that's x plus 2 squared. And positive 3, so that's x minus 3 with a multiplicity of 2, that's also squared. The constant term is negative 6. All right, so is this it? Well, how you want to check is you want to find out what the constant term would be if this was your answer. So that's 2 squared is 4 times negative 3 squared is 9. So that gives us a constant of 36. So how do I get 6 out of there? Yeah, divide by 6. Or what would be a good coefficient here? 1 over 6. And the negative here would make it negative 6. Okay? So that's how you determine the coefficient that might be in front. And there is your answer. Okay? Oh, goodness. Ah! All right. Any questions? Any issues about any of the examples I did today? All right. All right. So yeah. So those are the examples I wanted to go over with you just real quick in this final sort of review lesson.